Hello everyone. Today we are going to begin our lecture on the inferential studies for population proportions. Of course, we are going to learn how to find confidence intervals and perform hypothesis tests for population proportions. But before that, we need to understand what population proportions are and when and why we conduct studies on population proportions. Now, whenever we want to know whether a certain attribute has been met or not, in those situations, we perform studies on proportions. So we initially have to specify an attribute that we are looking for. For example, if I want to know what proportion of the population of students enrolled in statistics to pass the course, then I would conduct a study on proportions. I first would specify the attribute, which in this example would be passing the course. And then, of course, I would create my sample and then check in my sample what proportion of students pass the course. In other words, what proportion of students met the specified attribute I am looking for. All right. So those who met the specified attribute, it would be considered a success. All right. They met the specified attribute I'm looking for. And then those who didn't meet the attribute, that means those who are unable to pass the course, they would represent the failure end of the attribute. They didn't meet the specified attribute I was looking for. Therefore, in studies of population proportions, there are two possible outcomes. Either the specified attribute was met or the specified attribute was not met. So we will come up with different examples as we go through the lecture. But before that, I just wanted to give you an overview. We will learn how to find sample proportions, because like in any study, we will not work with the entire population. We will just work with our sample. Therefore, how do we calculate the sample proportion, which will represent the point estimate for our inferential studies? And then we will also first look into the distribution of the sample proportion before we can begin our study of inferences for population proportions, right? So as part of the inferential study, these are the topics that we are going to cover. Confidence intervals for one population proportion, then we'll talk about the hypothesis testing for one population proportion, and later on we will talk about comparing two population proportion, and that may go into another lecture. But we will first begin by understanding what population proportions are and when and why we conduct studies on population proportion, and then of course how to calculate sample proportions, what's the formula for that is, and what the distribution of sample proportion looks like. All right. So here we'll begin with a definition of population proportions, sample proportions, and the associated notations that go with them. All right. So it says here, consider a population in which each member either has or does not have a specified attribute. Then we use the following notation and terminology. So remember, I gave you the example of a specified attribute being whether a certain student has passed the statistics 2 course or hasn't passed a statistics 2 course. So in that case, my specified attribute was passing the course, and I would look at each member in the population or in the sample and check whether the person has met the specified attribute or didn't meet the specified attribute. Likewise, I may want to know what proportion of the population drives a particular brand of car. a particular model of car. In that case, the specified attribute would be, so let's say whether they drive a Honda, right? That's my specified attribute. So in my population or in my sample, I will look for particular members. I will look for each member rather, whether the member has met the particular attribute that in that case would be driving a Honda, or they do not drive a Honda, they drive something else and they did not meet the specified attribute. Now, population proportion is denoted by the letter P, and it says the proportion or percentage of the entire population that has the specified attribute. Recall that proportions can be translated into percentages. All right, when you take a proportion is a value between 0 and 1. Most often it is a decimal value between 0 and 1, and that can be transformed to percentage by multiplying it by 100, right? So when we are looking at the entire population and determining what proportion of the entire population has met the specified attribute, then we refer to that as population proportion, and we denote it by the letter small lowercase letter p. The sample proportion has a notation which is P with a hat symbol over it. All right, that denotes a sample proportion, and the proportion, a percentage of a sample from the population that has the specified attribute, is defined as sample proportion. So here we are going to learn how to compute the sample proportion, which is going to serve as our point estimate in our inferential studies and so on. Recall that a sample proportion has this notation. It's the lowercase letter p with the hat symbol above it. And in our sample study, we will have the sample size. We will know our sample size, and that's represented by the letter n, correct? N stands for sample size, and x denotes the number of members that have met the specified attribute we were looking for. So in other words, we will have our sample size, right? We will have, just a second, let me pull up the pen here. All right, we will have our sample size. All right, so here's our sample size. And out of the sample size, a certain number of members will have met the specified attribute. So I'm going to say that represents number of members meeting the specified attribute, meeting the attribute. All right, and to find out what proportion of members met the specified attribute, we just take x and divide by n. All right, so that is a very simple formula. It's x divided by n, p hat, is the sample proportion. So in order to find the sample proportion, of course, you will need to know the sample size, and you'll need to be told, or you'll need to know how many members met the specified attribute that we were looking for. To find out how many members didn't meet a specified attribute, we can easily find that out by performing n minus x. That means the total sample size minus the number of members that met the specified attribute would represent the number that didn't meet the attribute. All right, so n minus x, let me write that down here. N minus x represents those not meeting the attribute, the specified attribute. So what proportion would have not met the specified attribute? That can also be found using the same formula, but this time it would be n minus x divided by n. All right. So this is how you can find the success proportion and the failure proportion. Failure proportion in this context would be those who did not meet the specified attribute. So going back to the notes here, it says X denotes the number of members in the sample that have the specified attribute, and as usual, N denotes the sample size, right? So keep in mind, this is the formula to find the sample proportion. You need to calculate that first before you can go into further study of population proportions. So to continue a little longer on the topic of sample proportion and how to calculate it one more time, the notation for it is the lowercase p with the hat symbol over it. The formula is X divided by N, N being the sample size that we are working with. X represents the number of members in the sample with the specified attribute, and that is also referred to as successes. So whenever a member has met a certain attribute, the specified attribute, then that's regarded as a success. And if X is the number of members out of N meeting the specified attribute, representing the success, then the number of members not meeting the attribute would be N minus X, the total sample size, minus the number of members that met the attribute, right? So N minus X, and then, like we said previously, you can calculate the proportion of failures using the formula N minus X divided by N, all right? Now here we are going to spend a little bit of time going over the notation and comparing the notation for proportions versus the notation for means. All right. So we have two sets of notations. One is the parameter. The parameter represents any metrics, any measurements done on the entire population. Statistic represents the measurements performed on the sample. All right, so parameter, remember, you can use the mnemonics that parameter begins with a P and so does population. Any metrics on the population is a parameter. Any metrics on the sample, S, statistic. All right, SS, so statistic with S and sample with S. So when we are calculating means, the mean of the population is represented by this Greek letter called mu. The mean for the sample, the statistic, is X with a bar above it, right? As far as proportions is concerned, the letter P represents the population proportion, therefore the parameter, and P with a hat symbol above it represents the sample proportion, also called the statistic. All right? So let's work through a couple of examples. First, on identifying the two types of proportion, population proportion and sample proportion and their respective notations. And then we'll work on calculating the sample proportion. So let's read through this example. It says here, a survey polled 1,010 randomly selected US employees. The proportion of the 1,010 employees sampled who played hooky was used to estimate the proportion of all US employees who play hooky. Discuss the statistical notation and terminology used in this. Now, let me just explain what playing hooky means in case you're not familiar with that phrase. Playing hooky is when somebody just calls in sick when the person is not really sick but just wants to take a day off and relax at home. They just call in sick and don't go to work. That's what playing hooky is. All right. So I suppose some agency wanted to study what proportion of all US employees play hooky at least once a year or something like that. That was their study. That's what their study was about. So they want us to identify the two types of proportions from this wording and also their terminologies, right? So it says a survey poll. I'm going to read through it, and in statistics, for many of the word problems, and for all the word problems, I must say, it is imperative that you read the question over and over again, and then you need to extract the relevant data once you understand what the problem is about, and then go on to answering the questions. All right. So here it says a survey polled 1,010 randomly selected US employees. All right. So 1,010 represents a sample size, correct? It represents the sample size of what? Sample size drawn from where? From all US employees. So we can immediately see that our population here is all US employees, all right? And 1,010 is the sample size. All right. So the population proportion, we have to identify what the population proportion is, represented by the letter P. It's the proportion of all US employees that play hooky. All right. That's the parameter. And the sample proportion, denoted by the P hat, is the proportion of the 1,010 US employee samples that play hooky. All right. So that is how we can identify the population proportion and the sample proportion. We'll now work through an example to calculate the sample proportion using the formula that we had learned for sample proportion, which is P hat equals X divided by N. It's the same example that we had seen previously in the slide before. Playing hooky from work. I'm going to read through it one more time because this has a piece of extra information that was not included in the previous slide. It says here, poll was conducted on 1,010 randomly selected US employees. The employees sampled were asked whether they play hooky, that is, call in sick at least once a year simply to relax at home. 202 responded yes. So the goal here is to calculate the sample proportion of success, that is, those who play hooky. So our specified attribute that we are trying to understand, that we are trying to study, is what proportion of US employees play hooky. That is our specified attribute, right? So anybody who answered yes to playing hooky would fall under the success proportion. Those who did not play hooky, those who don't play hooky, they did not meet the specified attribute we were looking for, would fall under the proportion of failures, right? So the first step is to understand what the problem is, of course. You may want to read it a few times to get that understanding, and then extract the data that you will need to do the calculation. So it's best to write out the formula that we will be using, because that will tell you what data you should be looking for. So I'm going to write here my P hat. The formula is P hat equals X divided by N, correct? So N represents the sample size, the total sample size. So we will need to find that out from the wording of the question, and X will represent the members who responded with a yes. So N will represent the 1,010 randomly selected US employees. So for N, I'm going to write 1010. This is our N. All right. So let me get here to this. 1,010 is what our N is, the sample size. And X would represent those that responded with a yes. So this is going to be our X. So X is 202, right? So now that we have the data we need for the computation, I'm going to write p hat equals x divided by n and plug in the value for x, which is 202. Plug in the value for n, which is 1010, and that should give us a proportion of 0.20. All right, so 0.20, a proportion of 0.20 played hooky from our sample. All right, so p hat is the notation that you should use, not p. The next part says calculate the sample proportion of failures. So you can do it two ways. Since we have now calculated p hat, so the failure would be 1 minus p hat. So let me write that down here. All right, the failure would be 1 minus p hat, right? Just because there are two outcomes possible, only two outcomes are possible in a study of proportions. Either they've met, we have the success, or the failure. Either they have met the specified attribute or they didn't, right? So out of the whole pool of our sample size, if 0.20 was the success proportion, then the failure proportion would be 1 minus 0.20. All right, so that would be 1 minus 0.20, which is going to be 0.80. Alternatively, if you haven't calculated the proportion, in those situations, you have to find n minus x to find the number that responded with a no. So that would be 1010 minus, and this is minus 202. All right, just a second here. Let me see. All right, so 202 would give us 808. And that would be the number of members that responded with no, they do not play hooky. And then to calculate the to calculate the failure proportion, you would just have to go 808 divided by 1010 would give us the same proportion of 0.8. Of course, if easier to just find p hat first, the success proportion, and then subtract it from 1 to get the proportion of failures. All right? Now let's talk about the sampling distribution of the sample proportion. Now, before we perform any inferential study, whether it's on means or whether it's on proportions, we have to know what the sampling distribution of the sample mean or the sample proportion is. What do we understand by sampling distribution of sample proportion? It means that if we were to collect all possible samples, all the different possible samples from the population, and find the mean of all the proportions, of all the sample proportions, that is, then what would the distribution look like? What would the mean be? What would the standard deviation be? I mean, it's not an exact value. We will work with formula, but the sampling distribution talks about three important parameters. One is the mean of the sample proportion. If you're working with sample means, then it'll be the mean of all the sample means. Since we are talking about the proportion, it'll be the mean of all the sample proportion, the standard deviation of all the possible sample proportions, and then finally what the shape of the distribution looks like. All right, so let me read through it. It says here the sampling distribution of the sample proportion. For samples of size n, the mean of all sample proportion equals the population proportion of mu sub p hat. That means the mean of all possible sample proportions will be equal to whatever the population proportion is. So says here the sample proportion is an unbiased estimator of the population proportion, right? So in other words, we use the sample proportion that we find using the formula x over n and our data values. That is going to be the estimator of the population proportion. As for the standard deviation, this is the formula sigma, which stands for population standard deviation of all possible sample proportions, is given by this formula, square root over p, which is the population proportion, multiplied by 1 minus p, which is the failure proportion, right? P represents the success proportion, whether it's of the population or whether it's p hat, which is the sample proportion. It's p, and 1 minus p will therefore represent the failure proportion, divided by n. This is the formula for the standard deviation. As for the distribution, the shape, it says p hat is approximately normally distributed for large sample sizes, denoted by n. All right. So if n is large, the possible sample proportions for samples of size n have a normal distribution with mean of p and standard deviation given by this formula, square root over p times 1 minus p divided by n. So there should be a division sign which is missing. So let me see if I can just write it down here. This should be over here between 1 minus p and n. There should be a division sign. All right, so let me try to fix that here. I can't see the pen. Sorry about that. So it's going to be here. Sorry, it's at the wrong place. So here I go. So p divided by n. All right. So, or you can write it as square root over p times 1 minus p divided by n. All right. You can write it this way too. So here we have used the slash sign to represent division. All right. So to reinforce, let's go over what we just talked about on the sampling distribution of sample proportions. It says here for a simple random sample of size n with a population proportion of p. They've talked about the shape here first. So the shape of the sampling distribution of p hat is approximately normal, provided n times p times 1 minus p is greater or equal to 10. Now this is an assumption, this is a condition that needs to be fulfilled in order to assume that the shape is going to be normal. All right, so n being the sample size, p being the population proportion, and then 1 minus p, where when you do this calculation, that should be greater or equal to 10. There's the mean. Again, like I said, the sampling distribution deals with 3 parameters: the mean, the standard deviation, and the shape. The mean of the sampling distribution of p hat is mu sub p hat, in notation form, is equal to whatever the population proportion is. So we use this sample proportion to estimate the population proportion. And then the standard deviation of the sampling distribution is given by this formula, which is p times 1 minus p. The bracket should be closed, divided by n, and then we have the square root. We have to take the square root of this entire expression. All right. Now finally, let's look at an example to find the sampling distribution of the sample proportion using the formulas that we had learned. So essentially what we are finding here is the mean and the standard deviation of the sampling distribution related to a sample size of 1010, given a population proportion of 0.191 or 19.1%. All right. So it says here, suppose that 19.1% of all employees play hooky. So since they are saying all employees, this refers to the population proportion. All right, we have to be given the population proportion when we are looking at the mean and standard deviation of the sampling distribution. Earlier, we had found the sample proportion, which was 0.20. Here, this is not 0.20. On the contrary, this is the population proportion of 0.191. Right, so suppose that 19.1% of all employees play hooky, that is that the population proportion is P equals 0.191. Then for samples of size 1010, the variable P hat is approximately normally distributed with a mean. How do we calculate the mean? Recall that based on the distribution that we had studied previously, it was mu sub P hat is equal to whatever the population proportion is. So we have been given the population proportion as 0.191. Just write that down. There's no calculation needed to find the mean. As far as the standard deviation of all population proportions, the standard deviation of all sample proportions of a particular sample size, in this case 1010, we will have to apply this formula. So this formula will be there on the formula sheet. You will have to look it up to do the calculation. It's square root over P multiplied by 1 minus P divided by N. Plug in the values for P, which is 0.191. And then 1 minus P is 1 minus 0.191 divided by N is 1010, which gives us a standard deviation value of 0.012. So to answer this question, you have to be given the population proportion. The sample proportion will not work here. You have to be given the population proportion as well as the sample size. To calculate the mean, you do not need to perform any computation. Just take whatever the population proportion is and write it down for the mean. For the standard deviation, of course, you will have to use the value of the proportion and the sample size and then perform a calculation. All right.